Today I'm going to do a close reading of a mathematical task, so I'm going to read this like a mathematician would. This task comes from a lesson titled Tiling a Patio from Navigating Through Algebra in Grades 3 through 5 from the Principles and Standards for School Mathematics Navigations series. Alfredo Gomez is designing square patios. Each patio has a square garden area in the center. Alfredo uses brown tiles to represent the soil of the garden. Around each garden, he designs a border of white tiles. The pictures show the three smallest patios that he can design with brown tiles for the garden and white tiles for the border. As we read the first sentence, Alfredo Gomez is designing square patios. We will first define the vocabulary term square. Activating prior knowledge, we know that a square is a quadrilateral or four-sided figure with four equal sides and four right angles. We also might discuss the word patios. This is an opportunity to connect our problem or mathematical task to the real world. What is a patio? What kinds of patios have you seen? Patios at home, a neighbor's house, a restaurant, maybe the YMCA? We may even want to search for pictures of patios to see what patios may look like, or even draw pictures of our dream patio and share those examples with one another. The second sentence reads, each patio has a square garden area in the center. The term each tells us there is more than one patio that we will be looking at, and as we read it in context, we can note that they all have something in common or alike. In this case, each square patio has a square center. Let's also draw our attention to the term area. What is area? Area is the amount of space inside a shape and measured in square units. The word center also describes where we find the square garden area inside the square patio. This is an important directional term to describe its location, as we represent our gardens using manipulatives or pictorial representations. We can also begin to visualize what the patios look like as we read and work through the problem. The problem continues to describe how Alfredo will represent the patios in a visual representation. Using brown tiles to represent the soil or the square area in the center, and the border of white tiles that surround each garden. Note the term around, which is much like the term center that we looked at in the second sentence of the problem. A round describes the location of the border. The pictures show the three smallest patios that he can design with brown tiles for the garden and white tiles for the border. As we read the last statement, we can focus on the part that states that we will be exploring the three small patios using the brown and white tiles that Alfredo described in the problem task. As we continue to understand and make sense of the problem, we may, as mathematicians, build our own models using brown and white tiles. As we begin to build ourselves, we begin to make our own connection to the models and can make conjectures or extend patterns. As the famous Chinese proverb goes, I hear and I forget, I see and I remember, I do and I understand. After building our own patios using tiles, we can record the number of white and brown tiles for each patio in a similar table like the one shown here. As mathematicians read problems and situations, they not only visualize and organize information given, but they extend the problem by asking questions and looking for answers and solutions to their questions. Sometimes even solutions might lead to more questions. The task goes on to investigate the pattern as we continue to look at Alfredo's patios and extend the pattern to larger patios. In this type of problem, students organize data in tables and graphs. They compute, make generalizations, and make connections between the physical representations of the patterns and their verbal and/or graphical descriptions. The idea of variables are unknown is addressed informally here as we look for patterns and make conjectures. This has been a close reading of Tiling a Patio from Navigating Through Algebra in grades 3 through 5 from the Principles and Standards for School Mathematics Navigation series.